recording. Nobody on Zoom today wants to share their video. Wow. Okay, guys, just be like that then. Oh, hello. There someone is. Thank you. It's always nice to see a face on there. All right. Okay. All right. So, can y'all see the notes? Okay, good deal. All right. So we are going to start with multiplying and dividing of integers. Okay. All right. So again, these notes are available on Canvas under modules. So you can print out the blank notes before class, which is what I recommend doing. And then the completed notes are also on there as well. So you can pull these up, completed notes, blank notes, anytime you want. All right. So if you multiply or divide two numbers that have the same sign, you're going to get a positive answer. If you do opposite signs, you're going to have a negative answer. So 5 times negative 3 is going to be negative 15. And then negative 7 times negative 2 equals positive 14. And negative 9 times 7 is going to equal negative 63. And then anything multiplied by 0 is also always going to equal 0. So negative 6 times 0 equals 0. $90 divided by negative 9 equals negative 10. Number 6 says negative 24 over negative 12. So that's the same thing as saying negative 24 divided by negative 12. So that's going to equal a positive 2. All right, negative 32 over 4. So in other words, negative 32 divided by 4 equals negative 8. And then 10 over 1, or in other words, 10 divided by 1 equals 10. All right, and then you can't really divide by 0. So anything over 0 or divided by 0 is going to be undefined. All right, so I remember that by saying 0 under is undefined. Anything divided by 0 just equals 0. So 0 over negative 15 equals 0. right, number 11, I have negative 912 divided by 57 divided by negative 8. So I'll just start with the first one. I know that's a negative divided by a positive, so I know that's going to be a negative answer. And then I'm just going to use long division. 57 into 912. So 57 would go into 91 one time. 1 times 57 is 57. And then 91 minus 57 is 34. Bring down the 2. And then let's see, how many times can 57 go into 342? I believe that's going to be 6. 57 times 6 is 342. So yeah, times 57 is 342. So the answer for that part is negative 16. So negative 16 divided by, bring this down, divided by negative 8. So negative 16 divided by negative 8 is going to equal positive 2. All right. All right, number 12, 105 divided by negative 3 divided or multiplied by negative 5. So we're going to just go straight across here. So the first thing we have to do is 105 divided by negative 3. So we know that's going to be a negative answer. And then let's just use long division, 3 into 105. So 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. And then we bring down the 5. And then 3 goes into 15 exactly 5 times. So that part gives us negative 35. Bring down the multiplied by negative 5 part. So a negative times a negative, we know that's going to be a positive. And 35 times 5 is 175. So 175 is the answer. All right, on number 13, we do need to do what's inside the parentheses first. So negative 8 divided by 2 equals negative 4. And then I'm just going to bring everything else down. So 16 divided by 4 times negative 4. And then I'm just going to go straight across. So 16 divided by 4 equals 4. And bring the rest down. So then it's 4 times negative 4. And 4 times negative 4 equals negative 16. Any questions about any of that? All right, next we're going to move on to fractions. Adding and subtracting of fractions. Okay, so if your fractions have the same denominator, then it's pretty straightforward. You're just going to keep that denominator, and then you're going to just add or subtract across the top. So 9/17 plus 2/17 equals 11/17. And 3/8 minus 7/8. So 3 minus 7 equals -4. So that's -4 over 8. But we need to simplify, or in other words, reduce that. So 4 goes into 4 one time, and 4 goes into 8 two times. So -1/2 is the final answer. All right. So if the fractions do not have the same denominator, then you need to figure out the common denominator first. Okay. So there's different ways of doing that. I'm going to show you how you can do it using a factor tree. So, for example, 4 is 2 times 2, and 6 is 2 times 3. So your LCD has to contain all the factors of each denominator. So whichever one has the most 2's, that's how many 2's need to go into your LCD. So there's 2 2's in 4, so that'll be 2 times 2. And then you also have a factor of 3 from the 6, so you have to include that as well. So if you multiply all those numbers together, that will equal your LCD. And that equals 12. So your LCD is 12. So your LCD has to be at least as large as both of your denominators. It can't be something that's smaller than those two denominators. It has to be something at least as big or bigger than both of those numbers. So you have to be able to rewrite your problem using 12 as the denominator for both fractions. So then you ask yourself, okay, so what do I have to multiply with 4 to equal 12? 3. So that means you also have to multiply the numerator by 3 as well. So 3 times 3 is 9. So 3/4 turns into 9 over 12. And then what do you have to multiply with 6 to get 12? 2. And so you have to multiply the numerator by 2 as well. So 1 times 2 is 2. So 1 over 6 turns into 2 over 12. All right, so we just rewrote the problem using the common denominator. So now we can just add these together. So 9 plus 2 is 11. So it's 11 over 12. All right, so the factors of 10 is 2 times 5. And then for 8, that would be 2 and 4, and then 4 breaks down to be 2 and 2. So the prime factors of 10 are 2 times 5, and the prime factors of 8 are 2 times 2 times 2. So in your LCD, whichever one has the most 2's, so you have 3 2's, so you need 3 2's here. And then you also need a 5. So all the factors from both of those denominators have to go in your LCD. And whichever one has like more 2's, that's how many 2's you have to have in your LCD. All right, so when you multiply all those together, you get 40. 40 is your LCD. And also, whenever we're subtracting with fractions, sometimes some people find it helpful to change it to, instead of a minus, change it to like plus a negative and put the negative there next to the 5. You don't have to, but it might be helpful. Okay, so you're going to rewrite the problem with the denominator of 40 on both fractions. Okay. So you're going to ask, what do I multiply with this 10 to equal 40? That'll be 4. All right, 4 times 7 is 28. So when you ask yourself this question, there needs to be an answer. Meaning, what I mean by that is, you know, if there is nothing to multiply with this to equal that, then you have the wrong LCD. Okay, so what do I multiply with 8 to get 40? That would be 5. And negative 5 times 5 would be negative 25. All right. And then that gives me 3 over 40. All right, I want to show you another method that I like to use for adding and subtracting of fractions, and it's called the bow tie method. And this is just another option for you. You don't have to use this method at all if you don't want to, or you can use this method all the time if you want. It does work for any problem. So either way, personally, I use a different method for different problems, just depending on which one's easier for each problem. So for example, I like to use the bow tie method whenever the two denominators don't have any common factors. So for example, 5 and 6, you see, don't have any common factors. So to do the bow tie method, we're just going to cross multiply. So 1 times 6 is 6, plus 5 times 7, which is 35. So that gives us our numerator, over, and then to get the denominator, we're just going to multiply straight across the bottom. 5 times 6 is 30. And then we can just go ahead and add 6 plus 35 gives us 41. So we have 41 over 30. Any questions? Any questions? Come on now. Y'all okay with this answer? Don't have any objections? So, yes, so we're going to leave it like that. That is known as an improper fraction because the numerator is bigger than the denominator. But I don't really like the term improper fraction because it implies there's something wrong with it, which there's not. Just going to leave it like that. So some people think that in order to, simplify it, you have to change it to a mixed number. But that's not what we do need to simplify our fractions, but that just means we need to make sure they're reduced, which that is. You can't reduce it. You can change it to a mixed number, but we're not going to. Mixed numbers are great for some practical applications like cooking, like 1 3/4 of a cup or of something, is more helpful to say than like 7/4 of a cup or something like that. But in terms of doing arithmetic, then it's easier to just leave it as an improper fraction. All right, so number 6. So again, those two denominators of 7 and 12, they don't have any common factors. So I would love to use the bow tie method on this as well. And I would like to attach, change this to plus a -5 so I don't lose my negative. Okay, so 2 times 12 is 24, plus 7 times -5 is -35. over, and then 7 times 12 equals 84. So that's the same thing as saying 24 minus 35. So that's going to equal negative 11 over 84. All right. And if those of y'all that are watching on Zoom have any questions, feel free to just unmute yourself and yell at me if you need to. All right, number 7. So in this case, I'm looking at those two denominators, 6 and 9. And I see that they do have a common factor of 3. So I'm thinking that just using the LCD method might be easier for this problem, but you could still use the bow tie method. It's just that if you use the bow tie method, you're probably going to end up having to reduce it at the end. But either method will still work. So I'll go ahead and just do both methods, and then you can see the difference. So if we do the bow tie method, then we're going to cross multiply. So 5 times 9 is 45 plus 6 times 10 is 60 over 6 times 9, which is 54. And then 45 plus 60 is equal to 105. So 105 over 54. All right, so can we reduce that? And what can we reduce it by? Same thing, that was a common factor of 6 and 9. So if we divide both those by 3, all right, that's going to be 35 over 18. And I'm going to do that same problem using the LCD so you can kind of see the comparison. So if we wanted to find the LCD of those two, using factor trees, that's 2 and 3, and that's 3 and 3. So for the LCD, we need 1 factor of 2 and 2 factors of 3. So when we multiply those together, that equals 18. So we would rewrite the problem using 18 as the common denominator. And then we would ask, what do we have to multiply by 6 to get 18, which is 3, and 3 times 5 is 15. And what do we have to multiply by 9 to get 18? That's 2, and 2 times 10 is 20. And then we add them together, and that gives us 35 over 18. All right. So there you go. Okay. All right. All right. So number 8. So CD in this case means C times D. So you could say that the factors of that denominator are C and D. So what do you think is the LCD? So if I'm going to rewrite this problem using a common denominator, what do I want to put? What would I want to put here? D. Well, a lot of people say something like that. So if I put D here, then the next thing I would do is I would ask myself, what multiply with this to make it equal that? And there's no answer to that question because that's not my LCD. That would be, I think a lot of people get confused between the greatest common factor and the LCD. So D is the greatest common factor between these two, but that's not what we need. So that's the greatest common factor is something that's smaller that goes into, but we need the least common denominator, something bigger that both of those go into. So any other ideas of what the LCD is? CD is the LCD. So, you know, what do I multiply with this to get this? Well, I could say 1, or I could say I don't need to multiply anything because it's already there. And then what do I multiply with this to equal that? What is this missing? C. All right, so I just multiply by C. All right, C times 9, we could just call that 9C. Okay. So we just add across the top. Those are not like terms, so we can't combine them. So all we can do is just write down 8 plus 9C all over CD. Okay, number 9. In this case, we could just use the bow tie method because our denominators don't have any common factors. So x times 5, that would be 5x. And 3 times -2 would be -6. And that's all over 15. Any questions? All right. Number 10. So if I look at those two denominators, they definitely have common factor of A. So A would be the greatest common factor between those two. But what would be the LCD? So whenever you're trying to figure out the LCD, if one of your denominators goes into the other one, then that other bigger one is your LCD. So in this case, the LCD is A squared okay. So what do we need to multiply with a to equal a squared? A times a is a squared. And then this one, we don't have to multiply anything. It's already there. So my final answer is going to be negative a plus 3 all over a squared. All right. Any questions about that? Any questions about anything? All right. So if you, anybody on Zoom have any questions about anything? All right. If you have not gotten onto MyLabs Plus, please don't leave. That includes those of you that are on Zoom. Otherwise, I'm done. So I recommend printing out the notes for next time. You guys will be on Zoom. You guys will be in the class. Feel free to email me or text me anytime if you have any questions. Who needs help with MyLabs? Y'all know anything? If you have questions, y'all need to know anything. You know, you need tutorial hours. So you know where the academic sports center is? It's down there at the bottom of the hill. It's when you walk completely from the ground. Yeah, if you're going from here, you just go down that hill and it's like that. And so there's 12 tutorial hours required for the semester. You can go there and work on your homework and get help. You can also get the help from tutor. There's a link on Canvas. You have to go on Canvas. Okay, that's probably. This is your first semester, I guess. You haven't not even gone on Canvas at all. You might want to. You can go to it on your phone. Yeah, you can. That's right. You can that also. Did you do it by clicking on the link in Canvas? Those links aren't working right now, so you have to go. Do you have Firefox on there? So that by default, that Firefox is the only browser that will work. So I just look it up on Firefox. You can't just do MyLabs Plus, you have to do wc.mylabs Plus. Okay, so you have to go to Firefox, and you have to type in www.wc.mylabsplus.com. When you sign in, the username that you're going to use is the same one that you log into Canvas, and your password is your date of birth. You know how to go on Canvas? Okay. So have you taken math class here before? Okay. All right, we know how to go on Canvas. So basically what I just said, you need to do that. And that's where all the homework is. There's going to be 2 homework assignments to do on Tuesday before class. And then also on Canvas, I think as soon as you, if you're on the computer and you go in Canvas, like at the very top of that homepage is like a link to go in the Zoom class. And then I also send an announcement with that link on there. So I know like on your, if you go to the Canvas app on your phone, it doesn't show that homepage, but you just click on announcements and you'll see if you have that announcement, it has the Zoom class. It says yes. Yep. So go ahead and click on it. Getting the what? MyLab. Uh-huh. So yeah, just the first two are due on Tuesday, and then the next two will be due Thursday. So. So can you go to, okay, all right. And then also, how do we go back and watch the Zoom? I will, so the Zooms are on, I'm putting them on YouTube. I'll put a link, I'll send a link to the YouTube playlist. But if you want to just, if you're wanting to watch it, send me an email, remind me, and so and I'll send you that link. So I'm guessing you guys are all still here because you don't have MyLabs yet. Y'all can go ahead and unmute yourselves and talk to me. Mm-hmm. All right. So y'all need to go to the Firefox browser. Okay. And you need to type in www.wc.mylabsplus.com. And then to sign in, your username is the same one that you use for logging in Canvas. And your password is your date of birth with 8 digits. Are you? Did I call your name on the roll call? You might be in the wrong class. I don't know. Let's see here. Okay. What is your name? That's your last name or your last name? Okay. What's your last name? Okay. I think, yeah, I think Shantae called me about you yesterday, right? Okay, they still haven't got you on here. Let's see. You guys on Zoom have any questions? Have you been able to get in MyLabs Plus or what's going on?
I'm having trouble putting in my username. Like I put the same one I use my Canvas one, but it's not working.
If you're using your full email, like even the .edu or whatever, it might not let you in because for me, I had to remove the at whatever last portion. I had to put my name and then the number set. That might work for you, but I'm not too sure.
I'll try that.
Okay.
Okay, yeah, it worked. Thank
Okay.
you.
No problem.
Yeah, so, okay, so I see you are in there. We just need to contact, the Sandy on MyLabs. But can you send me an email? Do you have my email address? It's just Stephen at And your student ID number? Okay, if you can send me an email, with, you know, your name, your student ID number, and then which, and, like, remind me the class that you're in, like, and right now, and then, yeah, just send me an email and remind me that, I need to try to get you put in the system for Canvas and for my labs, and we should be able to get that done today. And then, yeah, then when you go to Canvas, you'll see it on there. And then, you should be able to do this then. Homework is on my own class. And like the notes and everything else is on there, and I have videos, so, so if you want, I'll be putting out the videos of the previous class. So, all right, so, yeah, we'll get it worked out. Okay, how are you guys doing? Okay, see ya. So once you get into My Labs Plus, you can always click on Pay Later or whatever if you don't have the access code, or you can buy it with your credit card. All right, Angelica, I can see that you got in now, right?
Yes.
Okay, so yeah, so you can just click on the homework once you get in there, and yeah, the first two, like I said, the first two assignments are due on Tuesday, and the next two are due Thursday. So,
Okay.
do you have any other questions?
Yes. I had 3 questions concerning the curriculum for today.
Okay.
Did you just want me to like just ask them real quick?
Okay, well, let me see if anybody else. Zoe, how are you doing?
I got it.
Okay. So you're Zoe Barber?
No, I'm Zoe Angeles.
Zoe Angeles. What about Jasmine? How are you doing?
It won't let me in.
Okay. America, I see that you got in.
Yeah.
Okay. All right. So if you're already in and you don't have any other questions, y'all can go. Let's see. All right. So Angelica, what were your other questions about?
So for the LCD, I was just confused on why we were only doing or I'm referring to example 4. But I was confused on why we weren't using all of the 2s and we just used the 2s from the, oh, let me pull that one up.
Okay. So you're just using like whichever one has the most number of 2s, that's how many you need.
Okay.
So like the 3 2s, it already takes care of the 1 2 that's on the other one.
Okay. It was confusing to me whenever I saw you.
Yeah, so like if you use all of the 2s, then you're not really finding the least common denominator. It's basically like you would just be multiplying the whole number over here and the whole number over there and multiplying them together. You know, if you use all of them, then there's like, you might as well just multiply the 2 numbers together. I don't know if that makes sense.
Yes.
But yeah, you just need, like, you only need whichever one has the most 2s, that's how many you need.
Okay.
Whichever one has the most threes, that's how many you need.
Okay, and then my second question refers to number 6, and all of the negative or subtraction, but you had a -5 and part of that
Mhm.
answer or the work. So I was wondering, is it always going to be that number, like the number on the second fraction on top?
Yeah, so
Okay.
that's why I changed it, is so it makes it more clear where that negative is supposed to go. So yeah,
Okay.
put
And then it
the,
will never go on the like it will never go on the 12th slot. It
right,
will always be okay.
right.
And then the last question pertains about use which method. I prefer the bow tie method, but I would be able to use that regardless as long as it's an adding and subtracting fractions,
Mhm.
correct?
Yep, yes. So you can use the bow tie method for any adding and subtracting of fractions. And as you can see, that one example that I did where, like I said, you just have to watch out for, having, like, if you have to reduce it later, you know what I mean?
Okay.
Like I did when I did number 7, I showed you can do the 2 different methods. If you
Oh,
do the bow
yes.
tie method, you have to make sure that you reduce it at the end.
Okay,
So
okay.
just make sure that anytime you're adding or subtracting fractions, or anytime you're doing anything with fractions, just make sure you check your answer at the end to see if it can be reduced at all.
Okay. Well, yeah, those were my 3 questions that I had.
Alrighty.
Okay. Thank you. Enjoy the rest of your day.
All right, you too.
What did you say was due on Tuesday?
Just the first 2 homeworks. Okay, Zoe Angeles, I can see you in the grade book now, so that's good.
Okay,
So
cool.
yeah, just the first 2 homework assignments, which is whatever we covered on Tuesday. So 1.2 absolute value, and then 1314, those are going to be due Tuesday.
Okay, cool.
And then the
Thank you.
next 2 will be due Thursday. But ideally, I would say try to get them all done if you can before next class,
Okay, well, I'm sorry. So absolute value, adding and subtracting integers, and what else was it?
So those, yeah, the first 2 are due Tuesday. Basically, the first 2 are due Tuesday, and the next 2 are due Thursday.
Okay, cool. All right, thank you.
Mm-hmm. Okay. So, do you have any other questions?
No, I don't think I.
Okie dokie. Well, I'll see you on Tuesday then.
Okay, bye.
Bye.